A warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, IIT Guwahati, course instructor for the NPTEL MOOC course Pavement Construction and Technology funded by Ministry of Education, Government of India. Today's lecture will be a part of the third lecture, Subgrade course and its functions under the module 2. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, Codal standards, journal articles, reports, newsletters and public domain searches. Now this particular lecture we will have a focus of our discussion especially on the features of a subgrade of a flexible pavement. Now this particular picture shows a section which has been cut to and where the information is available. You can see the part where this particular person is standing. This is your a compacted subgrade is there. So a section is there which shows the granular layers. These are the granular layers. These are the two granular layers which are shown. So on the bottom you can see you have a compacted subgrade. Then you have these granular materials. First layer granular materials, second layer, so and then granular material, your third layer. So these granular layers are constructed in multiple layers, and as we discussed in the previous lecture, these are sub-base courses, base courses. These are unbound courses. There is no binding material in these particular courses. And then on the top you can see there are two layers which are bituminous layers. The lower one is your binder course, and on the top one you have the surface or the wearing course. So all these layers we are able to see are resting on this particular prepared subgrade. Now if you have a good crust, what is above your subgrade is your pavement crust. If you have a good crust and which is constructed in a proper manner, then it will serve you the purpose of giving a smooth and comfortable ride, and it will last it will give a good performance for the design period. Now for our discussion on this particular subgrade aspect, different Codal specifications and manuals will be referred. Some of them are listed here on the right hand side. One is this orange book, which is from Ministry of Road Transport and Highways, which is a specification for road and bridge works. We call it as orange book. It is a very important book which refers to the various sections having information related to the construction of road and bridges. Then this is the IRC 34, which is there, recommendations for road construction in areas affected by waterlogging, flooding and all sorts infestation. So this is another code. Then we have the IRC 37, which is the code which gives the guidelines for the design of flexible pavements. We have IRC 36, recommended practice for construction of earth embankments and subgrade for road works. We have IRC SP 73, SP means special publication, manual of specifications and standards for two laning of highways with paved shoulders. We discussed yesterday what is a paved shoulder, what is an earthen shoulder. Then the IRC 75, which is their guidelines for the design of high embankments. So many more will be referred. These are few examples which are shown here. We have good IRC Codal and Ministry of Road Transport Highways specifications and codes available with us on this particular aspect. Now in our introductory lecture, when we discussed about especially what are the stages in which the road development has happened, there we discussed some of the traditional methods of the road construction also. And we discussed road in the ancient period, even during the during the Mohenjo-daro civilization, and even during the Roman periods. So a quick revamp of those information. We discussed in the case of Roman roads where informations are available. They used to construct roads putting up some big stones at the bottom and some big stones on the top, and there are finer stones with the presence of some lime mortar or concrete, they used to construct it. Now here they didn't use to provide any slope in this particular one, because the loads were not too heavy, but still the construction was very heavy. Now then the Tresegat method of road construction became popular in 18th century, where the construction involved the excavation of the soil, where they excavated the soil and followed by laying of larger stones. You can see here these bigger stones are placed here, bigger foundation stones are placed, but there is no slope which has been provided in the bigger stones. Then on the top the smaller stones are provided, and finally the top surface was having a slope. This slope was allowing the rainwater to drain from the surface. So this is what a conventional representation of the Tresegat method of construction. Then the Telford method of construction. Here you can see, even with the foundation stones, a slope was created. You can see on one side this the foundation stone height is 22 centimeter, on this side it is 17 centimeter. So with this particular one, the slope was introduced from the large foundation stones which were placed at the bottom, and then finer stones were over this particular one, and on the top again this particular slope followed. So this is how a good foundation firm foundation was introduced or was presented there in the Telford method. Now when macadam method came, till that particular point, whatever the new construction was there, that was the one which was given more emphasis. But when macadam, comparatively more emphasis, when macadam method came, the emphasis was given on the ground where all these layers are going to come. So the soil subgrade, it is the layer, it is over which the upcoming upcoming layers of your pavement crust will come. So it says that soil subgrade should have adequate density and kept drained. So this importance of subgrade was felt by the macadam method, and therefore you can see the slope was introduced from the subgrade itself. So subgrade was reconstructed, and when it was reconstructed, it was constructed to a desired density and water content, so as to get the required stability of the subgrade, and it was constructed with a slope considering the drainage requirements of this particular layer. So now this is to just give an idea how the importance of the subgrade came into picture, because finally all the layers which you are going to construct during a road construction, a flexible pavement construction, will be resting on some ground. So that ground needs to be prepared. Now if I have to construct a road, say this is my natural ground level, and because of any reasons, or this is a low lying area, waterlogged area, I may have to create some final surface at this particular level. So there may be a difference of say 5 meter. So what to do in this particular case? This 5 meter, because whatever your traffic requirement is there, it may require you a crust to be of say 1.5 meter. And then the ground which is to be prepared for these layers of your pavement crust may say take half a meter of this one. So this makes your 2 meter. Now still 3 meter is there. So when these levels are to be raised very high, this is done through the embankment construction. So the definition, what it says, an embankment is a raised structure made up of soil, gravel or lightweight material to prevent water overflow and support a road, because now your subgrade has to come over it, the level has to be raised so that there is no overflow of water over the road surface, otherwise the entire road gets submerged, and then if the road gets submerged, your connectivity is broken, and then it becomes challenge. So you want your surface should be available for traffic under any situation. So that's why you don't want it to get submerged under water. If it gets submerged under water, traffic cannot move over it, and then the purpose is lost. So that's why always we want to construct a road surface which is much above the water level or high flood level in that case. So, for this particular one, when you need to raise these levels which are very high, so you need to construct some more layers, and these layers will come under the embankment construction. These layers will be under your embankment construction. Now, you say what is there that, so the definition it says it is built by placing and compacting layers or lift of suitable materials placed on top of each other until it reaches the subgrade level, and all these layers are to be constructed using a selected material in a selected thickness and properly compacted to achieve a desired density also. Desired density will give you the desired requirements of strength also. An embankment is that portion of a roadway which has been built above the original natural ground. As I mentioned here, that when we are having this one, this is your natural ground level which you want to raise up to this particular level. So, it is the one which is constructed over the original natural ground by placing or depositing material obtained from cuts and borrow pits. Now, this much quantum of material which is required, when we will go into the construction discussion of subgrades, we will work out how much quantities of materials are also required. You can see this is the level has to be raised. See how much level has been raised here in this particular case. So, a good amount of material is to be required for this particular material, and this is mainly you will try to have some areas from nearby places also, because this huge quantity of material you cannot bring from far away locations, otherwise it will make your project very costly and it will be it will not be feasible also. This particular construction of embankment itself will become very costly. High embankments, a raised structure of height. There is another definition which is given as per IRC 75, which says high embankments, a raised structure of height 6 meter and above, built for the purpose of road transportation. So, this again gives some more information. So, for high embankments having a height more than 6 meters, we have Indian Roads Congress specifications IRC 75, which gives us the design guidelines regarding the construction of high embankments. Now, certain common things which needs to be looked into whenever these embankments are to be constructed, because most of the time you have to raise the level to a significant height, and this cannot be done by subgrade construction itself. You need to go for embankment construction, and there can be different scenarios under which embankment has to be constructed. So, one may be a routine case. What routine says is that when embankments are to be constructed over a firm ground, especially reasonably favorable ground using sand, and you have a good amount of sand, gravel and other approved fill. Approved means these are the materials which are approved to be used in an embankment construction, which may be in terms of their gradation, in terms of their strength, in terms of density, what type of material is to be, in terms of their plasticity index value, what type. So, any approved material, if there is a firm ground, then the construction becomes quite comfortable or easy, especially for the embankment part. But there may be certain cases where a part of a section may be having which may be a short stretch having soft or loose soil, or there may be some area which is waterlogged, because of which there is some marshy land has been created. So, and which is shallow, but this is for a small stretch only. So, in this particular case, or the embankment is made up of poor quality materials, or you have poor quality of material which is present for it. So, there in this case you can see this is an excavation of what can be done, whatever soil layers if it is there in a small stretch, it can be reduced, can be taken out, and then you can place any stabilized or any other material, suitable material which is as per the embankment material requirements, and you can compact it, you can place that new material, compact it and make the embankment ready for it. So, this is when it is a small stretch, this kind of exercise can be done. There can be some exceptional cases where the entire stretch is not having a good quality of soil available and the embankment is very poor. You cannot directly, that is the existing ground level, even if I doesn't need to raise the level, but then also my embankment is very poor in strength. So then it becomes a challenge. So there it says that the exceptional cases in which embankments are built over soft or unstable ground like marine clays, swamps, peats, creeks or floodplains, there is a high risk of instability and significant settlement. After construction, these soils may also swell or liquefy due to their loose nature even at deeper depths. So this have to be given a due consideration. Even you are doing an embankment construction and with a selected material, but then also, and these embankments are to be of greater heights, then over what kind of land that embankment and the construction is coming up, that also, if it is very weak, may be a challenging situation. So these factors need to be taken care when you are making an embankment construction. And what you are selecting for use of embankment construction, that is another concern, because it should as per the requirements. Now, and as I said, so when it is a significantly important factor that what foundation you give for your subgrade to come up and what is the foundation which is available for the embankment for construction. So the nature of foundation material has a significant influence on the design of embankment, because if the embankment is poor, the existing natural soil is very poor, then the embankment which has to be constructed, what type of material is to be used, what measures to be used, this is important. Another concern is that if you are, what type of slopes, if I am going to raise to great heights, what type of slopes is to be provided, if it is a waterlogged area, what type of measures related to the drainage aspect has to be taken care. Say for example, embankments resting on hard or favorable ground needs to be analyzed especially for only for slope failure. If a ground is good enough, firm enough, I am putting up some layers of embankment over it. My major concern will be with the slopes, what best slopes I can give, and a flatter the slope, the stable your embankment construction is there. Normally what is done, you compact it in the complete layers and then you create the slopes, because otherwise it is very difficult. So embankment construction, you can do the compaction in the entire width and then you can remove this particular part, so it gives you a good slopes also. So this is one aspect when you do the embankment construction over a hard ground. On the other hand, when embankments resting on soft grounds have to be analyzed not merely only for slope stability, but for base stability and settlements. So there are again the proper analysis has to be done whether the embankment which is to be constructed over the natural ground is good enough to take the load of the embankment. Then only if the analysis allows it, you go for the construction of the high embankments. While building embankments, one has to consider for economic reasons. Now the other concern is, if I say okay, underlying natural ground is weak enough, go get some good embankment, get some good material for embankment construction, but the quantum of material which is required is very high. So it is not possible I will give some borrow areas 50 kilometer away, 30 kilometer away to bring those good materials, and so certain regions may not be having good soil. So in that particular case, we have to go for some stabilization or other techniques, so as to use of geosynthetics. These kind of applications have to be introduced so as to strengthen your embankment or to get the desired strength. Several parameters, and what's several parameters in under this particular consideration will come into picture. Even seismic effect is there when you construct roads in hilly regions. This is again one concern. Nature of loads, acceptable performance criteria, what is the criteria. If it is a national highway, what the acceptance criteria will be very high, stricter, higher. Settlements, what type of settlements, bearing capacity, time available. For many times you don't get much, because there are certain regions in India especially where it rains for around 6 to 7 months. So you have a very small period for your construction. So all these things need to be, what type of material can be taken care. So that is how the IRC 75 gives the information, especially for these specific challenges. Now, as I mentioned, the side slope, when you have a firm ground, then the one major consideration is what type of side slopes you are going to provide. So the formation is usually graded to a cross slope. You will give a cross slope whenever you are going to put these layers, whether you construct a subgrade or an embankment, to facilitate the drainage to the side of the pavement. This is the purpose of it. The embankment is to be built with side slopes ranging from, it is 1 vertical in 1.5 horizontal, then or 1 vertical in 2 horizontal, which is in case of conditions which are unindentated conditions, that is, those are not typically flooded. That is, there you can have a slope of 1 vertical in 2 horizontal, that means a 50% is there. So this is one consideration. But where you have indentated situations or where the embankment is likely to submerge, you preferably go for flatter slopes up to 1 vertical in 3 horizontal, specifically because what the reason arises in waterlogged areas, you have the capillary rise is there, pore water pressure is there, because of which your effective stress gets reduced, and that reduces the shear strength of the soil. Now, because of this, the load carrying capacity is going to reduce. So there are chances that your structure may fail because of this particular embankment. So that's why it is always preferable when these waterlogged areas are there, that you give a flatter slope. Now so we need to make the things ready for the subgrade to come up over it, because this is the we will consider subgrade as the foundation of your pavement crust. But yes, as I mentioned, if the road level has to be raised up, then you have to come up with the embankment construction, and the subgrade is to be constructed over an existing natural soil. So the existing natural soil can be embankment, or if the level has to be raised, or it can be the natural ground level. Now what it says for subgrade is, it is the surface upon which the subbase, base and pavement layers are placed. So what is your pavement crust? So which consists of your subbase courses, your base courses, binder courses, your wearing courses or surface courses. So all these layers are going to come over your subgrade, and typically top 500 mm of the prepared foundation layer located at the bottom of your pavement crust. So if you have, say, on the top, this is my wearing course, I may have, this is the thickness of my wearing course, I will say wearing course, then I will have a binder course, then I will have a granular base course, then I will have a granular subbase course. These are, so after this I need, say, it says around 0.5 meter of your, this is your subgrade. So this, and the granular subbase course, here I am showing just as one layer. The thickness may be quite good enough, it may be, say, 40 centimeter. Here also this may be again, say, 35 centimeter. Your binder course may be, say, 150 or 100 mm, 10 centimeter. 10 centimeter may be your binder, this one, and then wearing course may be, say, 5 centimeter. So these all your layers up to this particular thickness have to rest over your subgrade. So this, it says the top 500 mm, this is, so the top 50 centimeter, half a meter of the prepared foundation layer located at the bottom of the pavement structure is designated as subgrade. Now this is a subgrade, and this, the specific thing is there. It is a subgrade which is constructed with controlled parameters. Controlled parameters means the soil characteristics are known to you, the density at which it is going to be compacted, the entire this 500 mm thickness, the composition and the construction information is there with us. So, it is a reconstructed thickness. Even if it is in a cut area, I have to go down, I have to cut up to the subgrade bottom. If there is a level, say if there is a part, if I will show you an information in this particular manner, there may be certain portions. If I am constructing a road in this manner, there may be, this is how it looks like. So, this is in a cut portion. Now, when in a cut portion, this may be erased. Here you may have to do some. So, this is, I have shown in a small, it is an exaggerated view, you will not find this kind of vertical gradient here. So, but my example is to show if there is a certain, at some portion you need to cut the existing land. When you need to cut the existing land, then also you have to go up to the subgrade bottom, and you have to remove the existing soil, and you have to reconstruct that subgrade. It should not happen that if there is an existing ground, so you are only, if this is my existing ground, you should never put up your pavement crust directly over it and just compact your top of it and call it as a subgrade. No, that is not the way you do it for the subgrade construction. You have to cut it down to the depth of at least 500 mm, you have to remove it, and whether this, if this existing soil is approved, then you can use this one, or you have to bring from the borrow material, or you have to treat it, stabilize it, and then you need to reconstruct this particular one, and you need to reconstruct it in different layers. It is not constructed, because if you are going to compact it only on the top, you doesn't know how what the soil is having at, say, at a depth of 20 centimeter. So, this is one concern. You should always go for the complete depth of your subgrade construction. Subgrade may consist of the original materials. As I said, if this material which is removed, and if you find that this material is good enough, then you have to reconstruct it to achieve the desired density. The important thing is, when I will recompact it, I will ensure the desired density, and I will ensure the desired slope also, which is to be there for my pavement crust. So, it may consist of the original materials as in cut sections, or hauled in materials. I may have to bring it some from nearby areas as in filled sections. This is the one definition. On new roads, the main aim should be to construct the pavement as far above the water table as economical practice, because this is a natural phenomenon. If you keep the level low enough, then definitely whenever some rains are there, heavy rains are there, your subgrade gets flooded with water. If it gets flooded with water, it loses its shear strength, and then the entire structure is resting on your subgrade. So, the entire structure fails. So, always we prefer to keep this particular one well above your water table. So, this is one important aspect which needs to be taken care. Now, what materials I can use? As I said, natural soil, existing soil you can use if it meets your requirements. Meet your requirements in terms of the strength and gradation. If it meets the requirement, you can use it. If it does not meet the requirement, you need to treat it, or you need to select some nearby areas from where you get this particular material. So, subgrade is primarily the bottommost layer, which is usually made up of in situ material. I can use the in situ material, select soil, some borrow area soil which I can, or some stabilized soil. Certain soils I may require to stabilize. If a clay soil is there, I need to stabilize it. If even we have black cotton soils, that needs to be stabilized, and then there are different methods. You might have read, you might be reading in other courses where soil stabilization is one part, that you do different kind of stabilization techniques for treating. Some smaller aspects will be discussed later also. So, you may have to do some stabilization for improving the strength of the soil, characteristics of the soil. So, this is the requirement of IRC 37. The material used in the embankment or in the subgrade or in the earthen shoulders. As I mentioned, we have paved shoulders. Paved shoulders more or less similar composition as the main your carriageway. Then earthen shoulders are there. So, in your earthen shoulders or in your embankment or in your subgrade, the materials used are more or less quite similar. And backfills also, when some flyovers or other structures are constructed, backfill materials, what we use there? We use soil, we use the muram. Now muram is another term you might have had. This is reddish brown color soil is there, which is slightly more granular. Soil is a general term which is there for inorganic, organic matter, air, water, which comes from the decomposition of rocks, which comes from plants and animals decomposition. So the soil forms out of these many components, and a specific type of soil is muram, which especially comes from the weathering of rocks, and which is granular and especially reddish brown in color. So this is what a muram is used. So this is also quite frequently used wherever it is available. Or you can use even we look for use of some industrial waste also. Fly ash is there. We have a pond ash, which is a combination of fly ash and bottom ash, which is also used. And as a mixture of these, and these can be mixed together. Even alone fly ash, it may be difficult to construct with a fly ash alone. So you may use a certain percentage of fly ash with the existing soil, and then you can use it. So a combination of these materials can be used. Finally, this have to be approved by the engineer in charge. So what this combination cannot be used directly without you get a prior permission by the engineer in charge of the project. And how he will give the approval? He will give the approval on the basis of the specifications which are available. The material used in the subgrade shall satisfy the design strength criteria. Say one criteria is the strength, and strength, many Codal specifications specify the strength in terms of the California bearing ratio. This we will discuss when we will characterize the or design the, we will look into the design and characterization of subgrade soil. So this is one strength parameter which is known as California bearing ratio. So strength can be measured in terms of California bearing ratio, and if it meets out that particular, say if I fix up that my California bearing ratio, this should be at least 5%. So whatever soil I use in subgrade should have a strength which is at least of 5%. CBR value should be, this California bearing ratio value should be at least 5%. Then I can use it. So depending upon what type of construction is there and what the guidelines says about it on the strength of that materials, you can use it once it has been approved by the engineer in charge, and he will use these Codal specifications to select whether this material is suitable or not suitable. Now as I said, again there is always a concern, this forms a important foundation for your pavement structure. So you need to keep this one, the level of this one in a proper manner, so that it does not get submerged by water. So it says that normally in plain areas, road subgrade elevation in fill sections, especially when fill sections is there, the top of the subgrade shall be at least 0.5 meter above the original ground level in non-flood areas. As I mentioned that we normally construct at least, that is why we construct at least 50 centimeter of the subgrade, because it should be at least from natural ground level, it should be at least 50 centimeter above it. So here you can see this is the natural ground level, and it says that this subgrade should be, the top of the subgrade should be at least 50 centimeters. So this is my top of the subgrade. Now the other part says road passing through terrain in flooded areas. What happens if there are flooded areas? You say the bottom of the subgrade shall be at least 0.5 to 1 meter above the high flood level. So even if the area gets flooded, then also my subgrade should not get affected. It says that the subgrade bottom should be having a height of at least 0.5 to 1 meter above your high flood level. So that, because if any flooding is there, then also your subgrade does not get affected. If subgrade does not get affected, it does not damages your pavement structure or reduces the stability of your pavement structure. So the level at which a subgrade is constructed, it is very, very important, and you need to ensure that the entire thickness of the subgrade is constructed with a controlled material, to a controlled specification that is in terms of density and strength. So, whenever a road is to be constructed, this is very important that you ensure that this thickness of subgrade has been constructed with an approved material to a given density requirement. Unfortunately, many a times the subgrade falls in waterlogged areas. If that falls, it raises a big concern. It is always mentioned all Codal specifications similar, because as I know, as soon as water enters into your subgrade, it loses its strength. When it loses its strength, all layers which are resting, which are ultimately transferring your load to the subgrade, will get distressed, and if they will get distressed in flexible pavement, that distress or undulation or distresses will ultimately get reflected on the top. So, it is essential to keep the subgrade above the high water table to prevent damage to the pavement due to surface water and capillary water, because there will be a capillary rise which will be there, and because of so we need to have a capillary fringe. Up to a certain level the water rises, it creates a pore water pressure, and that leads to a reduction in the shear strength of the soil. So, always that is why we want to keep this water level well below at least 1 to 1.5 meter to your subgrade bottom. So, and to maintain the design standards with respect to the vertical alignment. So, whenever you design any road section through any particular region, this information has to be properly collected, so that the height of the subgrade is adequately considered during the construction. In waterlogged areas, subgrade saturation from capillary rise, seepage or pavement infiltration reduces its load carrying capacity. As pavement strength depends upon the subgrade support, this leads to weaker pavement layers, and with constant traffic and reduced subgrade strength accelerates the pavement deterioration. Now, even what happens if during subgrade construction I have selected a good soil and good density parameters, but unfortunately because of some challenges, if I am not using the soil which has been selected for it, I am using a soil which is having a strength lesser than what was considered during the design, then the entire pavement structure will again fail, because your pavement crust is designed considering the strength of your subgrade, and the subgrade, why you rely on it, because you have reconstructed the subgrade with a selected material to a selected density. But if that goes down, the entire your pavement crust will not serve the purpose. So, even if you have constructed the above layers to the required standards, but then also you will find that the entire pavement structure in due course of time may fail, because there was a problem with the type of subgrade material which you have used. So, this is one important concern. Always when you begin construction, it is the subgrade from where you have to be very cautious for the pavement quality. Now, you can have different, if there are certain areas where you find some challenges are there with respect to the there is a high amount of water logging is there, standing water is there, then what to do in that particular case? You can take some extra measures also, some precautions can be also taken. Say here it is shown that in case of this is deep drains, you can go for deep drains for lowering water table in embankment. Now, what is done here in this case? 1.5 to 1.8 meter deep drainage channels. This is one drainage channel which is created, which is around 1.5 to 1.8 meter deep drainage channels which are constructed, and these are below the natural ground level. Now, this as close to the road bank are provided for depressing the level of subsoil water. If any water which is there, and weep holes are provided. So, any water which is there will enter into this particular one instead of entering into your embankment and your subgrade. So, instead of disturbing, I am providing this easy path for the collection and removal of the I'll say subsoil water. So, this measure will be effective in keeping the bottom of the subgrade above the capillary fringe. So, this is one way I can do. This will help me especially when the waterlogged areas are there. This is so this is a one way I can do for keeping this particular one the water level below my subgrade. The other way is where now this, but this is again a costly exercise. This is not a, and throughout the length if you have to do. The other way around is what is to be done is, if I cannot go for these especially deep drainage channels, what I have to do, I have to raise the level. So, here where it is too expensive for or impractical to provide deep drainage channels throughout the length, it is recommended that an embankment of such height should be provided. Then I will put an embankment, I will raise the embankment. In that case, embankment construction has to be done that the bottom of the subgrade remains at least 1.5 meters. So, my concern will be I will raise the level, so that what is there, that my bottom of I'll raise it in such a manner, and I'll construct it. These are my embankment layers. And I'm not given a uniform thickness. All layers will be constructed in a uniform thickness. So, don't take it in this manner that I showed this. So, uniform thickness have to be there. Now, this I'll put up the embankment construction, so that finally the subgrade bottom, which is here, is at least 1.5 meter from the high flood level. So, if I am not able to go with these deep drainage channels, then I have to go with raising my level of the subgrade bottom through the embankment construction. So, this is another measure which is very important to consider, so that you keep your subgrade well protected from the water, so that it is at least 1 to 1.5 meter above your high flood water level. At least not 1, it should be at 1.5 meter above your high water flood level. And the thickness which you construct, which should be at least 50 centimeter of your subgrade should be constructed. So, with this particular one, we have discussed some of the salient features of the subgrade soil, and we will discuss further more aspects of it in the next lecture. Thank you.